The variables in this differential equation cannot be separated, and so we want to develop a method that uses something called the integrating factor to solve differential equations of this form. Hello there and welcome to the channel. My name is Ferguson Mangoma. So let's get cracking and rewrite our differential equation over here so we can sort out this integrating factor. So it is dy dx minus 3y is equal to 0. That's our differential equation. Now, what is the integrating factor? Let's call it I. The integrating factor I is something of this form. I is equal to e raised to the power p dx. Wait a minute, don't panic. I know this looks ugly, but you will get everything explained. So I is equal to e raised to the power the integral of p dx. Once we have found this integrating factor, we then rewrite our differential equation as y multiplied by our integrating factor e to the power p dx is equal to the integral of whatever is on the right-hand side, the right-hand side multiplied also by our integrating factor e to the power integral p dx. All this, of course, with respect to x. Now let's look at it very carefully. I know it looks ugly. I know it looks intimidating, but wait till we put in the numbers. It's a straightforward thing. What it says here is, once we get here, we multiply our y by the integrating factor here, but we also multiply the function on the right-hand side by the integrating factor, and we integrate with respect to x. Now, let's test this with our differential equation. What is p? P is all that which is multiplying y. Look at that. What is the coefficient of y, or the function that is multiplying y? It's actually minus 3. In this case, it's a constant. It could be a function of x, but in our case here, it's a constant. So p is minus 3. So then the integrating factor becomes let's say I here is equal to e to the power integral of minus 3 dx. Look here, there is our 3, there is our p there. And of course, this is just e to the power minus 3x. That is our integrating factor. So we come down here, we substitute for everything. It then becomes here y multiplied by e to the power minus 3x is equal to the integral of the right-hand side, in our case here, is 0 multiplied by e to the power minus 3x with respect to x. This, of course, becomes what do we differentiate and get 0? It must be a constant. So this is a constant because all this, of course, is equal to 0. So we are integrating 0 with respect to x. When we integrate 0 with respect to x, we get a constant. And let's call that constant c. So we have y e to the power minus 3x is equal to c. When we multiply both sides by e to the power minus 3x, we do get y is equal to c e to the power 3x. That's the solution to our differential equation. Let's go step by step with what we have done. First of all, we must find our integrating factor. Our integrating factor is e to the power p dx, where p is the function multiplying y. In our case, it's just a constant, it's minus 3. So our integrating factor becomes e to the power integral of 3 dx, which simplifies to that. Once we have done that, we come to this equation here. We substitute for the integrating factor, and we say y is equal to y multiplied by our integrating factor, which is that, is equal to the right-hand side, the integral of the right-hand side, multiplied by our integrating factor, which in our case was 0 times e to the power x with respect to x. Of course, this gives us 0. So integrating 0 with respect to x, we get a constant c. And here we just